video, we shall go over how ray diagramming is done for convex lenses. We shall be solving two problems to help us make sense of the process. For the first problem, let's locate the image formed by a 1 cm object placed in front of a convex lens with a focal length of 5 cm. Here is how it's done. First, we draw a horizontal line to represent the principal axis and a symbol to represent a thin convex lens. Then we mark the position of focus prime or f' on the side of the lens where the object is located, and that of focus or f on the other side. We also mark points called 2f' and 2f. The side where you see the object is our front of the lens, and this is where we see the f' and the 2f'. By the way, the focal points are located using the lens's focal length. We multiply the focal length by 2 to get the location of 2f and 2f'. Now, we draw the object standing upright on the principal axis, following its correct height and its correct distance from the vertex. We can use an upright arrow to represent the object. We move on by representing light rays using arrows to show how the light is refracted. Although there are many possible rays that we can use, 3 rays will be enough. We shall be using the principal ray, the focal ray, and the vertex ray. To draw the principal ray, we create a line that is parallel to the principal axis. This connects the tip of the object with the lens through the normal line. This is refracted or bent through the principal focus f. To draw the focal ray, we create a line that connects the tip of the object with the principal focus f'. Then we let it hit the lens through the normal line. This then refracts parallel to the principal axis. Finally, we add the vertex ray. This is a line that passes through the lens's vertex and travels straight on. Now, we can draw the image of the object with its tail on the principal axis. The point where the 3 rays meet or converge is where the tip of the image is. Once done with the diagram, we can now describe the nature of the image by identifying its location, orientation, size, and type. In our example, the image formed has the following characteristics. It is located behind the lens at beyond 2f. It is inverted, magnified, and real. It is inverted because its orientation is opposite to that of the object. It is magnified because it appears larger than the object. And finally, it's real because the image was formed when actual light rays converged. These solid lines represent actual refracted rays. Let's do one more example. Say we maintain other parameters, but we move the same object closer to the lens at 3 centimeters. Notice that the object is now between the focus and the vertex. Our procedures will still remain the same. We still do procedures 1 to 4. However, we will notice that the refracted rays do not meet behind the lens. They actually diverged after refraction. So what do? We extend the refracted rays towards the object side by using dotted or dashed lines until they meet. These dotted lines represent virtual light rays. The point where they meet or converge is where the tip of the object is. Now, we draw the image of the object with its tail on the principal axis. Finally, we describe the nature of the image by identifying its location, orientation, size, and type. In our example, the image formed has the following characteristics. It is found in front of the lens, its orientation is upright, its size is magnified, and we call it a virtual image. It is described as upright because it's oriented in the same way as the object. It's magnified because it's larger than the object, and it is virtual because the image was formed by virtual light rays, which is symbolized by the dotted or dashed lines. Virtual images cannot be projected on a screen. You might also notice that the virtual images tend to be upright. So here is a summary of what we've done so far. Remember, convex lenses can form real or virtual images depending on the location of the object. A virtual image is guaranteed when you put the object between the focus and the vertex, while you get a real image when you situate the object after and beyond the focus. I hope you got it. Thanks for watching.